Boring? Okay, let's look at page 574, number 8. So this tells us a statistics student heard that an individual's arm span is equal to the individual's height. To test this hypothesis, the student used a random sample of 10 students and obtained the following data. So part A. I need to know if this is independent or dependent. That's really the difference in the two sections we learned. If we are looking at a student and measuring their height and their arm span, is that independent or dependent data? Dependent. It's matched pairs data. They are connected. So that means we do it where what would be our null hypothesis? That when we had dependent data, we looked at the difference. And both of them were essentially assuming that the means are equal to each other, but we wrote it a little bit differently. When we had that dependent data, we did the matched pairs. We talked about the difference in that L3. So my null hypothesis would be that the mean of the difference is 0. We are trying to test, if we're looking at part B, does the sample evidence contradict the belief that an individual's height and arm span are the same? So what would be my alternative hypothesis? Okay. Then how do we set this up? Calculate. So go to so we need to clear out whatever we have. And we want to enter the height in L1. And we all need to make sure we do it the same. We also have to make sure that you put these in order because it's like an X and a Y, so you can't just jumble them up. Questions? And then what did we do on this matched pair statement? We went to list 3. If you go up on top of the title of the list, then we can do L1, so second number 1, minus L2, second number 2, L2. And that will go ahead and subtract them all for us. All right. Now, anytime we're talking about a mean, what test do we do for our hypothesis? So we go to stat, test, number 2, t-test. We're basing it off of data or stats? Data. Okay, the mean of the null is 0. My list should be L3 because we want to run it off the difference. Frequency is 1, set it at not equal. So calculate. So our t is negative 0.5124 or 21. The probability is 0.6209. Remember, in general, you reject P is less than alpha. And that's always, regardless of what type of test we're running. So is my P less than alpha? No. So that means we fail to reject. If I ask for a sentence, it means there is not sufficient evidence to conclude that we're looking at height and arm span. Are different. Does that mean they are the same? No, I didn't prove that they were the same. I just failed to prove that they were different. All right. You guys remember this? So when our data is matched pairs, that means when it's dependent data, when it's connected somehow, that's when we do the three lists, L1, L2, and then the third list being the difference. Your null hypothesis is assuming that the difference is 0. Let's look at one more review problem. Let's look at page 576. Look at number 9. Okay, so researchers had a car traveling 10 miles per hour collide into the rear bumper of an SUV and recorded the amount of damage in dollars. The data is below. Do the given data suggest that the repair cost for the car is higher? Use the alpha equals 0.01. So sorry, 0.1 level. Okay, so we have an SUV, we have car damage. What type is this? Are these independent or dependent? So we're looking at, was I testing like a before and after or anything like that? No, so that kind of leads you to think independent, but look carefully. Are they? And in one accident, the SUV and the car, wasn't that those two collided? This is how much it costs for the SUV and this is how much it costs for the car. So because those two are connected in that one accident, that's still matched pairs data. You guys see that? So this is still the 11.2, the exact same thing we just did. I just wanted to throw another one of those at you to make sure you understand. Sometimes it's from one person, but here it was, one accident. Here's the damage from each of those. So we would do it the same as the previous one. Okay. I'm not actually going to work that one out, but I just wanted to mention it. Let's look at number 7. So a researcher wants to know whether the acidity of rain near Houston, Texas is significantly different from that near Chicago, Illinois. He randomly selects 12 rain dates in Texas and 14 rain dates in Illinois to obtain the following data. So part A, is that independent or dependent? Independent. Are those two related in any way? No, it's from two different cities. It wasn't even like on one day it rained in both cities and I compared the rain. It's just random days. Another clue, do we even have the same number of points from both? No, so there's no way it could be matched pairs data. B, because the sample sizes are small, what must be true regarding the populations for us to be able to do anything? What has to be true? Normally we say bigger than 30, but it's not, so what else has to be true about the data? Normal. If it's not bigger than 30, it has to be normal to begin with. All right, we're going to skip C. We're going to look at D. So, does the evidence suggest that there is a difference in the pH of rain in Chicago and Houston? All right. So, what is my null hypothesis? The mean of the first is equal to the mean of the second. When they're independent, we just assume they're equal to start with. My alternative, I want to know if they are different. So what would it be? 9. If I wanted to see if Texas was higher, Texas was the first one, so it'd be the mean of the first is greater than the mean of the second. Okay, now what? Calculator. Clear out everything that's there. Okay. Did we do the difference on this one? I think I missed a point, didn't I? Okay, I'm missing one on mine. So my values are going to be off. I'm not going to take the time to try to find it here. All right. What do I need to do then? What test do we go to? Good. Stat test. We're normally talking about a t-test, but I can't do the regular t-test because we have 2 different samples.
0.
4. So number 4 is a 2-sample t-test. 0 is talking about the 2-sample t interval. So if I ask for the confidence interval, that's what you would go through. All right, we're basing off data. List 1 should be L1, list 2 should be L2. We are testing not equal to. Pooled, just leave that as no every time. Calculate. So my T is 2.2763. Okay. I was going to say, I think I found the point I missed. Our probability is 0.0387. We reject if P is less than alpha. Alpha on this one was 0.05. So P is less than alpha, so we reject the null hypothesis. So that means there is enough evidence to conclude that the acidity of the rain is different in the 2 cities. Okay. Any questions for me? So those are the 2 types that we've done, and you have the rest of the hour to work on homework.